Alright, so now let us talk about permeability. But first, let us define what does the word permeability means. It is the property of the soil to transmit water and air. So soils are permeable due to the existence of interconnected voids through which water can flow from points of high energy to points of low energy. So the study of the flow of water through permeable soil media is important in soil mechanics. It is necessary for estimating the quantity of underground seepage under various hydraulic conditions, for investigating problems involving the pumping of water for underground construction, and for making stability analysis of earth dams and earth retaining structures that are subject to seepage forces. So I know we are all familiar with Bernoulli's equation. So from fluid mechanics, we know that according to Bernoulli's equation, the total head at a point in water under motion can be given by the sum of the pressure, the velocity, and the elevation heads, or H, or the total head, no, is equal to the pressure head, which is equal to pressure over the unit weight of water, plus the velocity head, which is equal to velocity squared over 2 times the acceleration due to gravity, plus elevation head, which is equal to z. So note that the elevation z here is the vertical distance of a given point above or below a datum plane. So the pressure head is the water pressure U at that point divided by the unit weight of water, or gamma water. So if Bernoulli's equation is applied to the flow of water through a porous soil medium, the term containing the velocity head can be neglected because the seepage velocity is relatively small, and the total head at any point can be adequately represented by this one na lang. So wala na ilabot, no, katong formula for the velocity head, because according to Brahadas, no, um, the seepage velocity of the water, no, penetrating the porous soil is very small, so hence it is almost negligible. So that's why it is not included in the computation of the total head in the water motion or the water movement in a porous soil. So we have here, no, a figure that shows the relationship among pressure, elevation, and total heads for the flow of water through a soil. So this is the soil strata, and then this is porous soil, meaning it allows water to flow through it, no, na direction diri sa atong flow. So we have here, as we have learned, no, in our fluid mechanics na subject, we have gotten to know the piezometers, which are open standpipes, no, that are inserted into the porous soil, so we can get the pressure of the water inside this one. So open standpipes called piezometers are installed at points A and then B. So the levels to which water rises in the piezometer tubes situated at points A and B are known as the piezometric levels of points A and B respectively. The pressure head at the point is the height of the vertical column of water in the piezometer rather installed at that point. So kung pilay gisa ka, no? Pilay gisa upon the insertion of this piezometer into the porous soil, the water will rise, and the pressure, no, the pressure head at this point is the vertical height, or the height of the vertical column of the water in this piezometer, specific piezometer. So the loss of head between 2 points A and B can be given by this formula. So the loss, or the head loss, or the loss of head, is equal to HA, which is this one. Kay H is, the head is always reckoned rather, is always reckoned from the datum line. So HA minus HB. So that is our head loss. So expanding no the formula um for the head loss, which is this one, no, as discussed in the previous slide, katong Bernoulli's equation nga wala nang gi-appeal ang si page velocity. So mo ni siyang formula kay base sa head loss. So it can also be expressed no in a non-dimensional matter or form, which is equal to I is equal to the delta H, or the head loss, over L, where I in here is the hydraulic gradient and L is the distance between points A and B, that is the length of the flow over which the loss of head occurred. So basically, more slope, no? This is the rise and this is the run. So actually, hydraulic gradient is very much, plays a very big role when it comes to flow of water in a porous soil. So this formula can also be used interchangeably or whenever possible or whenever applicable together with these equations. So let us talk more about hydraulic gradient. So when the hydraulic gradient is increased gradually, so meaning hydraulic gradient, it is actually slope, no? The rise, which is the head loss, over the length the length of the flow of water, or the distance between 2 points. So that is hydraulic gradient is a slope. So if it is increased gradually, the flow remains laminar, no? We have here in the illustration on the right, in the zone 1 and 2, as the hydraulic gradient is increased gradually, our velocity also is represented on the y-axis. So as the hydraulic gradient is increased gradually, the flow remains laminar in zones 1 and 2, this one, and the velocity v bears a linear relationship to the hydraulic gradient, no? Um, Almost straight siya, meaning linear relationship. So kung pilay dako or pilay move, pilay increase atong hydraulic gradient dire, mo po'y pag-increase on mo po'y amount nag-increase sa atong velocity. So mo na ang relationship ngayang bot pasabot dire in zones 1 and 2. Laminar meaning steady flow man na siya, no? Dili siya turbulent flow. Um, So at a higher, so we know that if we increase our hydraulic gradient, no, so at a higher hydraulic gradient, the flow becomes turbulent, which is now we are in zone 3. Kay taas naman ang hydraulic gradient diri, no? Taas na kay bali ang slope, no? Uh, sa water flow day rather. So, kung mag-anam og kadako ang hydraulic gradient, mag-anam og ka-turbulent ang atong flow sa atong water. So, when the hydraulic gradient is decreased, laminar flow conditions exist only in zone 1. So, in most soils, the flow of water through the void spaces can be considered laminar. So, meaning, this can be interpreted through the equation or through the expression, velocity is directly proportional to the hydraulic gradient. So, mo ni siya, no? Nga symbol. So, in fractured rocks, stones, gravels, and very coarse sands, turbulent flow conditions may exist. So, this equation may not be valid. So, now let us talk about Darcy. So, in 1856, Darcy published a single equation for the discharge velocity of water through saturated soils, which may be expressed as V is equal to Ki. So, V in here is the discharge velocity, which is the quantity of water flowing in unit time. And K in here is the hydraulic conductivity, or our coefficient of permeability. So, this equation was based primarily on Darcy's observations about the flow of water through clean sand. So note that these two equations below, no, uh, are similar and both are valid for laminar flow conditions and applicable for a wide range of soils. So muna siya ganyan, no? our discharge velocity is directly proportional to our hydraulic gradient. So if we convert this statement, no, or expression into an equation, we would have to replace this symbol here with the equal sign, and we would have to add the coefficient here, which is the letter K, or which represents our coefficient of permeability. So V, no, more on Darcy's law, V is the discharge velocity of water based on the gross cross-sectional area of the soil. So however, the actual velocity of water, that is the seepage velocity, through the void spaces is greater than V. So we should not be confused with seepage velocity and discharge velocity. No? A relationship between the discharge velocity and the seepage velocity can be derived by referring to this figure here, which shows a soil of length L with a gross cross-sectional area A. So, na siya there, no? Alright, so if the quantity of the water flowing through the soil in unit time is Q, we know that Q is the rate of flow, magina siya, no? Which is equal to A times velocity, or yes, the discharge velocity, or equal to the area of the voids times the seepage velocity, or seepage velocity is equal to the discharge velocity over the porosity. So now let us talk about hydraulic conductivity, no. Katong V is equal to Ki according to Darcy. We have already talked about the I, which is the hydraulic gradient, and the Q, which is the rate of flow. And then now let us talk about the letter K, no, and what does it represent? That is the hydraulic conductivity. It is the ability of the porous medium, or the soil, for instance, to transmit water and under or nearly saturated condition. So this is somehow a measure, no, of how how much can a soil allow, no, how much can a soil transmit water through it. So hydraulic conductivity is generally expressed in centimeters per second or meters per second in SI units, and in foot per minute or foot per day in English units. So the hydraulic conductivity of soils depends on several factors: fluid viscosity, pore size distribution, grain size distribution, void ratio, roughness of minerals, and degree of soil saturation. So, in clay soils, structure plays an important role in hydraulic conductivity. So, other major factors that affect the permeability of clays are the ionic concentration and thickness of layers of water held on to the clay particles. So, the value of hydraulic conductivity K varies widely for different soils. So some typical values for saturated soils we have here, no. The hydraulic conductivity of unsaturated soils is lower and increases rapidly with the degree of saturation. So for clean gravel, um, if we focus in here, no, in the unit centimeter per second for our hydraulic conductivity. So, nagkandalain-lain nga soil type, nagkandalain-lain po siya nga hydraulic conductivity. So, as we can see here, no, kung magkaanam og kagamay ang particle sa atong soil, mas magkaanam po og kagamay ang atong hydraulic conductivity, because we have here, for the clean gravel, dako siya, no, 100 daw to 1 centimeter per second ang water flow. However, for our clay, it is just 0.000001 centimeter per second. So, meaning, mas dali ipenetrate sa water ang clean gravel, no, kaysa sa clay. That is somehow what it is trying to tell us with this table. So the hydraulic conductivity of a soil is also related to the properties of the fluid rather, flowing through it by equation. K is equal to gamma water over the viscosity of water times the absolute permeability. So, this is another equation for our hydraulic conductivity if we base um, our determination of it sa properties of the fluid flowing through our soil. So, mo ni siya to gamiton. Gamma water is the unit weight of water which is constant man, no? And in here, or kani siya nga symbol, which represents the viscosity of water, and K bar is the absolute permeability. So, gamma water kabalo naman ta, no? And then, for the viscosity of water, it is already given, no? Actually, viscosity of water is very much dependent on the temperature, no? Na siya kan nagkandala ilahi. So, depende na lang tayo on the property of the fluid that we are considering. Mag-base lang dahil ta sa atong value sa viscosity for our water. So, we all, as much as other properties of our soil, no? The determination of the hydraulic conductivity of our soil can also be done in the laboratory through two most common methods. We have the constant head permeability and the falling head permeability test. So let us first talk about the constant head permeability test. So a typical arrangement of the constant head permeability test is shown in this figure. Now, in this type of laboratory setup, the water supply at the inlet, this one, so in ani kibali yung itsura, no? Na water inlet diri. Now, it is adjusted in such a way that the difference of head between the inlet and the outlet remains constant during the test period. So, after a constant flow rate is established, water is collected in a graduated flask for a known duration. So, the total volume of the water collected in this flask may be expressed by this equation. So, Q is equal to A V times T, or kablo ta diri no ang atong discharge velocity is equal to KI. So if we, and since I in here is the hydraulic gradient, which is equal to the slope, H over L, no? Um, the pressure head over the length of flow. So if we transform this formula, it will become to this one. So meaning, if we compute or if we determine the hydraulic conductivity of our soil through constant head permeability test, this is the formula that we are going to use. So no other formula will be used in the computation for our hydraulic conductivity when we use constant head permeability test. So this will always be the equation that we are going to use. So K is equal to QL over AHT rather, where Q in here is the volume of the water collected. So you have to be very keen, no, or observant. This is capital letter Q. No, it is not the same with the small letter q that we refer to as the rate of flow. So ang Q diri is the volume of the water collected. L is the length of the specimen. A is the area of cross-section of the soil specimen, which you can determine already, no, by measuring it manually. H is the pressure head, no, it can be computed by this one or determined through measuring. And T is the duration of water collection. So in this test, no, i-allow lang siya, no, this is actually the porous soil, and then sudlan siya tubig dara, and then syempre if this is porous enough, no, this water in here from this inlet will penetrate this soil, and then mugawas din siya diri. So this test, no, this water will be allowed to penetrate this soil over a certain period of time, man. So that time is what this letter T in here represents for. So now let us talk about falling head permeability test. So same nagyapon yung mechanism, no? A water will be allowed to penetrate the soil, and then measurement will be conducted later on. So, inalahi lang siya itsura, no? Inaani lang siya. We have a standpipe. Now, a typical arrangement, this is the typical arrangement of the falling head permeability test, no? Water from a standpipe flows through the soil. So, diri maagi ang water, no? Mo-penetrate dayon siya sa atong soil. So, the initial head difference H1, we have H1 here. At time t is equal to 0 is recorded, and water is allowed to flow through the soil specimen such that the final head difference at time t2 is H2. Okay. Siyempre, if magbutang tagtubig din, no, we measure that as H1, and then if we allow that water to penetrate this soil over time until muubos man gina siya, no, kay siyempre makuhaan gina siya diri kay mo penetrate mo ng ubang tubig dire. So ang katong tubig nga from diri pa unta siya, since na penetrate na ang uban, muubos gid siya dire. So that is our H2 at time 2. So we can compute our hydraulic conductivity, which is denoted by small letter k. No, same lang siya sa katong constant head permeability. Ang isolve ra gid nato diri is the hydraulic conductivity or the coefficient of permeability, which is the letter K in here in the formula, no? It can be, no, from the book of Brahadas, it could be solved or determined through this equation, no? Na yung mga constant diri, the log 10, and the 2.303. We have the A, which is the cross-sectional area of the standpipe. The capital letter A, which is the cross-sectional area of the soil specimen, and the L in here is the length of the specimen, which is this one, and H1 and H2 are those recorded, no, before and after the test. So in other review books, hydraulic conductivity using falling head permeability test can also be determined or solved through this equation. Mas less kuan siya, no, mas less complicated siya tan-awon. Pareha ra siya og mga variable, pareha ra siya formation, no, sa mga yang parameters diri. Ang nakalahian lang is ang function, no, nagamit siya diri log, and then diri is ln. So pareha lang, no, L over T, and then A over capital letter A, pareha man siya, oh, pareha ra siya og position. Ln lang gamit diri is log H1 over H2. So I prefer to use this one, no, kay mas dali siya i-memorize, and then mas gamay ra pud imong tuplokon sa calculator when solving. So anyways, either of the two you will use, you will still arrive in the same value for your hydraulic conductivity using falling head permeability test. So, mo lang na siya, no? Wala po ilaing formula that you are going to use for the determination of your K using falling head permeability test. Kanira po siya. So, doesn't matter what the problem gives you when it asks for the hydraulic conductivity using falling head permeability test, kanira gid siya ang imuhang gamiton. So same pod, no, sa constant head permeability test. Okay, so we have here a sample problem, no. First, let us have a sample problem for the constant head permeability. So we have here figure A, no. A test gives these values. So, katong L is already given, A is already given, constant head difference H is given, water collected in a period of 5 minutes, ang time na to diri is 5 minutes. The volume of the water collected is 250 cubic centimeter. So the same na gyapon, no, in any problems that we have to deal with units, we have to be very careful of the units that are given and the units that we are asked for. So if they're in cases na 5 minutes man ang given sa time, and then ana siya dire, calculate the hydraulic conductivity in centimeters per second. So sa centimeters parehan, okay na tanong kay parehan naman tanan. So dili na lang sa 5 minutes, which we have to convert later on into seconds. So when we talk about constant head permeability, kani siya nga equation automatic ang atong gamiton walay lain jud siya. K is equal to QL over AHT, no? Given ang Q, which is 350 cubic centimeters, ang L is 30 centimeters, A, or the area of the specimen, is equal to 177 square centimeters, and our constant head is equal to 50 centimeters, and the time of our test is 5 minutes, which later on we have to convert into seconds. So substituting these given values to our equation, we come up with the value of our constant head permeability test, hydraulic conductivity, no, or the hydraulic conductivity using constant head permeability test is equal to 3.95 times 10 to the third centimeters per second. So, board exam problems related to this one will only look like this. So, it is only a matter of you memorizing the formula for the hydraulic conductivity for each of these tests. So, sa falling head permeability test pod, no? Isa ra pud ka formula ang gamiton dire. So, muna siya ang problem na given ang mga values for the length of the specimen, the area of the soil specimen, the area of the standpipe, muna siya ang small letter A and the big letter A, no? And the head difference at time 0 or H1, which is equal to 20 inches, and H2, no, after 180 seconds, which is our T, which H2 now becomes 12 inches. So we are asked to determine for the hydraulic conductivity of our soil in inches per second. So okay na tanan, no, sa atong mga units because we're already in inches and in seconds as well. So automatically, when we are given with a problem about falling head permeability test, kani nga formula ginatong gamiton or katong kaganihan, no, katong na ILN. Actually, masayon to siya memorization, and in the board exam, it is more adapted than this one. Kay mas gamay man yung tuplo ko, no? So, anyways, in this problem, so this problem is by Brahadas man, no? So, he is using this formula. Actually, if you actually use the other equation, you will still arrive in the same value for your hydraulic conductivity. So, muna siyang formula, no, for our hydraulic conductivity. If we use the falling head permeability test, so we are given the value of our um, area for our standpipe, which is equal to 0.06 inches squared. The length of the specimen, or capital letter L, is equal to 8 inches. Area of the specimen is equal to 1.6 inches squared. And the time of the test is 180 seconds. H1 is 20 inches and H2 is 300 millimeters. So, substituting, no? Simple lang kayo. Substituting these values into our equation, then we can arrive with the value of our hydraulic conductivity using the falling head permeability test, which is equal to 8.52 times 10 to the negative 4 inches per second. So that is how you deal with the problem about falling head permeability test, and as well as katong kaganiha, which is about constant head permeability test. So basically, board exam problems related to this one somehow looks like this lang man. So you just have to memorize the formula and then identify which parameter is given, no, para sakto imuhang mas-substitute to come up with the right answer. So we also have the relationships for hydraulic conductivity, no? Dependent on what is given in the problem. If the shrinkage factor and the void ratio, no, are given, so you can use this equation. But as much as we have the weight and volume relationship, no, nga makagamit ta sa nagkandalahi-lahi nga equation dependent on what is given in the problem. So mo pwede yang pasabot ani, no, we can solve for our hydraulic conductivity using what is given in the problem. So if the D10, D sub 10, no, gikan man ni siya sa sieve analysis of our soil, the void ratio, we can directly solve for our hydraulic conductivity using these values alone So basing na ay problem no about hydraulic conductivity, and then ang given lang is void ratio, d sub 10 no, and then the Cu. So for granular soil, so depende on the given, what if are given tong kaganihan no, katong H, katong mga area of the specimen, wala to sila gi-state, and then you're asked to solve for the hydraulic conductivity using what is given in the problem. So at least you know how to, or you know that there are equations that exist no, establishing the relationships for hydraulic conductivity. So it also applies to the cohesive soils no. We have here the void ratio. So, masolve na to kibali ang hydraulic conductivity kung kanilang sila nga mga parameters or data or properties of the soil ang given. So, now let us talk about directional variation of permeability. So, most soils are not isotropic with respect to permeability. So, in a given soil deposit, like this one, the magnitude of K changes with respect to the direction of flow. So, figure in here shows a soil layer through which water flows in a direction inclined at an angle with the vertical, which is the alpha. So, let the hydraulic conductivity in the vertical and the horizontal directions be KV and KH respectively. So, murag gi-anticipate lang niya, no? Now, what if the flow of the water is with an angle, no? At an angle with the vertical. So, we have to get the K equivalent, no? In the vertical, and K horizontal, which is the KV and KH respectively. So, the magnitudes of KV and KH in a given soil depend on several factors, including the method of deposition in the field. So we have the equivalent hydraulic conductivity stratified soil. So in a stratified soil deposit where the hydraulic conductivity for flow in a given direction changes from layer to layer. So an equivalent hydraulic conductivity can be computed to simplify. So if the problem is asking us for the K horizontal no hydraulic conductivity in horizontal direction, or the equivalent hydraulic conductivity in horizontal direction, muna siya nga formula atong gamiton. Kay murag gibutang niya in consideration nga ang flow of the water within our soil strata is not uniform. So, it could be at an angle with the vertical. It could be in any other direction. So, at least we can express, or we can get the horizontal and vertical lang nga equivalent sa atong hydraulic conductivity regardless of the flow of direction. So, diretso lang tano. Ang formula sa KH equivalent is equal to 1 over H, which is the total height or the total thickness of our soil strata, times KH1. K in here is the coefficient of permeability in this specific layer 1, for example, we have it dito na lang. We have a layer 1 na siya iyahang lahi nga hydraulic conductivity, dapat siya iyang specific nga height. So, i-times din mo na siya kada isa, and then you just have to sum up kada product no of each of the hydraulic conductivity times yung H, KV, KH rather, KH times H2, KH3 times H3. So, isam lang nimo na siya. Then, you will get your KH equivalent. So, we have for the vertical direction, no? Same lang gyapon ang formula. Formula nga mga parameters, no? Still the H, which is the total thickness. And then the H1, no, thickness of layer 1, and the coefficient of permeability or hydraulic conductivity of layer 1, plus, kaganihan, no, kung ano man to siya, no, product, dire, is, you have to divide the, hydraulic conductivity from the thickness of that layer. So when asked for the hydraulic conductivity or equivalent hydraulic conductivity in vertical direction, automatically this is the equation that we are going to use. So we have here a sample problem, no? A stratified soil with different layers or 3 layers. Given ang H1, H2, and H3 and their specific nga hydraulic conductivity, no? K1, K2, and K3. So diri nga case na determine na kibali ang hydraulic conductivity sa atong layer, kada layer sa atong soil. So we have to estimate the ratio of the equivalent hydraulic conductivity KH over KV. So you have to compute for our KH and then KV. So automatic lang, no, katong formula kaganiya for our KH, kana lang siya nga formula, and then substitute lang nato ang values for the total thickness, which is equal to H1 plus H2 plus H3, and then KH1, K K1, which is 10 to the negative 4, H1 times H1 is equal to 2 given, no? So isam lang na nimo tanan ilang product, and then you will get the KH equivalent, which is equal to 107.07 times 10 to the negative 4 centimeters per second. So the same with the horizontal direction, no, of equivalent hydraulic conductivity given na magid siya daan ang equation. You just have to substitute the given values for you to come up with the answer. So muna siya ang K vertical equivalent kibali, which is equal to 0.765 times 10 to the negative 4 centimeters per second. So gisubstitute ra pud ang mga values nga given ani. So since the problem is asking us for the ratio of the horizontal over the vertical equivalent, so we just have to divide them, and then we come up with the ratio equal to 139.96. So you also have a problem here. Figure here, figure 7.2 shows 3 layers of soil in a tube that is 100 millimeters by 100 millimeters in cross section. So water is supplied to maintain a constant head difference of 300 millimeters across the sample. So the hydraulic conductivities of the soils in the direction of flow through them are as follows. So given soil A, soil B, and soil C, and then their respective hydraulic conductivity. So we are asked to solve for the rate of flow in water in cubic centimeters per hour. So cubic centimeter per hour is actually the rate of flow. The volume over rate or over time is actually the rate of flow, that is equal to Q is equal to KIA, wherein ang atong gamiton na K dire is the equivalent nga katong vertical, kay ang flow sa atong water dire is vertical man. So we just have to use the formula to get the equivalent, no? And then that K is now what we use as our governing K or hydraulic conductivity in the computation of our rate of flow. So we just have to substitute all the given values to come up with our answer. So we also have another method of permeability test in the field, no, which is through pumping from wells. So in the field, the average hydraulic conductivity of a soil deposit in the direction of flow can be determined by performing pumping tests from wells, no, aside from the laboratory test, which are the constant head and the falling head, no. If we try to determine the hydraulic conductivity on site or in the field, this is how we determine it, no. So during the test, water is pumped out at a constant rate from a test well that has a perforated casing. So several observation wells at various radial distances are made around the test well. So continuous observations of the water level in the test well and in the observation wells are made after the start of the pumping until a steady state is reached. So the steady state is established when the water level in the test and observation wells becomes constant. So we have two ways, no, of permeability test on site or on the field. We have the unconfined aquifer and the confined aquifer. So sa unconfined aquifer, we do not necessarily have to confuse ourselves, no, automatically if we are given a problem about an unconfined aquifer. This data will be given. We just have to use this formula specifically if in the problem it is well stated that we are having an unconfined aquifer as our pumping well. So automatically, we just have to use this formula, no? So, mukibali na siyang actual situation if we conduct a permeability test in the field, no, through an unconfined aquifer. So, there is a case where the top permeable layer whose hydraulic conductivity has to be determined. So, it is unconfined and underlain by an impermeable layer. So, muna siyang ginatawag og unconfined aquifer. So, sa mga problems related to this one, no, pumping wells with an unconfined aquifer, given ni siyang mga data, mga distances, and mga dimensions, and mga measurements, we just have to memorize this formula, or this one, no. This equation na kayo nasa babaw is based from Brahadas, and this one kayo nasa ubos is based from the review books, no. So actually pareha ra ni silang duha ng equation, depende na lang kung asa ang mas comfortable mo nga gamitan, pero I prefer this one because mas gamay ra ay imong tuplokon sa calculator, so mas dali ka makasolve. So again, when given a problem about unconfined aquifer and you are asked for the hydraulic conductivity out of the data from that, so you just have to use this formula and then input all the given data. So as well as for the confined aquifer, no? So the average hydraulic conductivity for a confined aquifer can also be determined by conducting a pumping test from a well with a perforated casing that penetrates the full depth of the aquifer, and by observing the piezometric level in a number of observation wells at a various radials. So, no? Radial mga R. So, pumping is continued at a uniform rate Q until a steady state is reached. So, again, if you are given with a problem about confined aquifer and you're asked for the hydraulic conductivity, you just have to use this formula, no? Established formula, for you to come up or to arrive with your hydraulic conductivity that is being asked in the problem. So anyways, in the problems related to confined and unconfined aquifer, the data or the illustration like this one will always be given. So it's up to you to memorize the formula for that. So that would be all for the permeability of soil.